The question here is to show that the reciprocal lattice vectors form a lattice, meaning if you take two of those and you add them, then the result is also a reciprocal lattice vector. So do pause the video and try to convince yourself of this simple fact. So this is almost embarrassingly easy, but let's do this anyhow. So first of all, let's say we have a first reciprocal lattice vector, G1. What does that mean? It means that exponential minus j G1R, that should be equal to 1 for all possible lattice vectors in real space. If you have a second lattice vector, then you just write down the following, that this guy is also 1 regardless of which value of R you choose. And then what we now need to prove is that if you have a new lattice vector, which is just the sum of these previous two, so G1 plus G2, then in that particular case, that should also be equal to 1, again, for all possible lattice vectors in real space that you pick. Pretty trivial. 1 times 1 is indeed equal to 1. Now, by extension, this means that if you take these two reciprocal lattice vectors the same, that twice a vector is also part of that lattice, and by extension, also any integer multiple of a reciprocal lattice vector is again a reciprocal lattice vector.